Hey guys, in the last lecture we were talking about properties of integrals, and we wanted to study properties of integrals because this guy in other words, the fundamental theorem of calculus part 1 involve the integral. So maybe getting to know the integral might help us with this computation. And again, this computation is great for us because it makes it so that we don't have to compute that crazy limit. Now with that said, I want to dig in a little further here and start studying the relationship between this big f of x and this little f of x. And in this particular lecture, we're going to start thinking about it from a graphical perspective. And I'm also going to give this an actual name. So here's a definition. If the derivative of big F of x is little f of x, we say that big F of x is an antiderivative of little f of x. Now I underlined something here. I underlined the word and there's a reason for this. If you think back to Calc 1, when you took the derivative of a function, there was only one answer. You were done. But I wonder if things are so straightforward if we go backwards. Well, let's do an example. So as one example, blank is an antiderivative of 1. So let me give you a second, press pause, and see if you can come up with this. Right, well, I thought of the function x. X is an antiderivative of 1. Why? Because the derivative of x is 1. So that's an antiderivative of 1. In other words, the derivative of x is 1. Well, some of you may not have chosen x. So as an example, maybe somebody out there chose x plus 2. Is x plus 2 an antiderivative of 1 as well? Sure is, because the derivative of x plus 2 is 1. In fact, if you start thinking about it, there are an infinite number of answers to this question, both correct and incorrect. All the correct ones are of the form x plus some constant. So the constant here is plus 0, the constant here is plus 2. But if I add a constant and I take a derivative of that sum, the constant's going to go away. So in other words, the derivative of x plus c, where c is any constant, would work. So instead of then saying that there is one antiderivative, we say that little f of x has an entire family of antiderivatives. So it's not just one function, but it's an entire family of antiderivatives. And how are these guys related graphically? How is x plus 2, x plus c related graphically? Well, if you think about it, what we're doing is we're taking our function, let's say f of x, a little f of x equals x. And if we're adding c, then we're adding c to the y values. So what we're doing is we're shifting this guy up and down. So this might be x plus 2. This might be x minus 2. But the entire family can then be constructed by vertical shifts of any one of those particular functions. All right, so let's actually write that down. we can construct the family using vertical shifts. All right, so now I'd like to give you guys a couple of examples. I'll put them on the board. Hopefully you'll pause the video and give them a shot yourself, and then I'll go over them. All right, so these examples, again, are helping us to understand the relationship between a function and its family of antiderivatives from a graphical perspective. So here's an example using notation from last quarter or differential calculus, wherever you took it. So given little f prime, given f prime of x, let's sketch f of x, little f of x, if little f of 0 is 0. That'll be one question. Second one is f of 0 equals 2. And let me give you a picture. So here's negative 2. Here's negative 1. So we have this function, and just cleaning it up a little bit. Okay, so there we go. So this guy's negative 2, this guy's negative 1, and this is a picture of f prime of x. So we want to sketch f of x with these two conditions. So first I want to have you guys realize something. This is language from last quarter, f prime of x and f of x. This quarter, we're using f of x and big F of x to denote the relationship. So in other words, it doesn't actually matter which I use. We have to understand that the derivative of this function, the big F of x, is always going to be this guy. And from last quarter, the derivative of this is this. So regardless, I'm given information about some derivative, given information about a derivative, and I want to sketch the original function. So I want to start you guys off, but then I would like you to stop the video and see if you can finish things off by yourself. So the first question that I have is, what information about f prime will be helpful in getting a rough sketch of my f function, my little f function here? And hopefully you're thinking, well, it's important to know whether f prime is positive or negative, because that'll tell me if my original function is increasing or decreasing. So with that in mind, at negative 2, so this is a f prime of x sign chart, 0. So I'm putting those guys on there because f prime is positive here, f prime is negative here, f prime is positive here. So I'd like you to stop the video now, see if you can finish this problem for both 1 and 2. All right, hopefully you give that a shot. Since f prime is positive, f of x increases. F prime is negative, f of x decreases. F prime is positive, increases. So what are my pictures going to look like then? Well, let me draw it right below here so I can use these values to help me sketch it. So in the first one, f of 0 is 0. So I just need to draw a function that increases, decreases, increases. So pretty much those arrows spell it out for me, right? Increases, this again is my f of x function. Increases, decreases, and then increases once again. And let me also point something out, that this guy is some sort of cubic. This guy is some sort of square function. So I'm happy about that because the derivative of a cubic is a square function. Finally, with f of 0 equal to 2, all I'm going to do is just bump this up. So what I can do for the second one is just copy it over, and I'm literally shifting it up this way. Sorry, my curves don't look exactly the same over there, but hopefully you get the idea. that I just took it and bumped it up that way. All right, so I've got 2 more examples that I want to put on the board. And for these, once again, I'd like you to try them, press pause on the video, and then I'll go over them. So here's an example. Say you are told that f prime of x looks like this. And before you even dig into this one, find f of x. Let's do it where f of 0 happens to be 1. Before you even do it, if you look at that guy, this guy's a linear function. So you know that your answer better be some sort of quadratic function because the derivative of a square is a linear function. So give this problem a shot and then press play again to see the solution. Right, once again, what I do is a sign chart. And what I'm interested in is knowing where this guy is positive, where this guy's negative. So at 1, it switches over. F prime is positive here. F prime is negative over here. I find it helpful to then do my sketch right below the axis so that I can see what's going on. I also find it helpful to actually write in my f of x. So f of x is increasing because f prime is positive. F of x is decreasing because f prime is negative. And this goes into 1. F of 0 is equal to 1. So I'm going to go through that point. So I'm going to increase to there and then decrease. So increase, decrease. Boom. There it is. It's an upside down parabola. In fact, I'm not surprised by that. Because even though it's not the exact parabola, if I start with minus x squared and I take the derivative, I get minus 2x. And the point that I want to make is that the slope is negative, and this guy has a negative slope. Again, this function isn't exactly this function, but I just wanted to point that out. All right, I have one final example for this lecture. And once again, I invite you to try it out first without actually looking at the solution. So this guy, this. So this one's a little bit more interesting. This one is f prime of x again. And once again, let's find f of x if f of 0, let's say, equals 2. So give this one a shot. So hopefully you did this. You said to yourself, well, f prime of x, let's see, it's going to be 0 at 3. And f prime of x is positive and positive. Well, what does that tell you about f of x? It tells you it's increasing to 3. And then it's increasing after 3. So what interesting thing is happening at 3? Hopefully you said a horizontal tangent line because the slope is 0. So what would this look like? So f of 0 is equal to 2, so it's going to go through that point. So I need to increase horizontal tangent line. Say horizontal tangent line over there. I could do a better job at that. To me, sorry. Sometimes, I have to be honest, it's easier to sketch it and then put in the numbers after, but hopefully you get the idea. We have a horizontal tangent line over here, and the function is increasing on either side. So in summary, the big ideas of this lecture are to realize that first off, if you want to find the antiderivative, you're out of luck. What you'll be doing is you can find an antiderivative, or even start thinking that there's a whole family of antiderivatives related to each function. Second, that family is related by plus c. So what that means is that the whole family is related by a series of vertical shifts.